Today's lesson is lesson number 4, application problems of fraction unit rates. So we're going to be working with word problems. To begin today, you have an on your own review problem. So you should be able to do this. Pause the video, come back, and then check your answers. On your own says Maggie reads 1/5 of a book in 3/4 of an hour. How much of her book can she read in 1 hour? Because I'm looking for 1 hour, I know hours is going to go on the bottom, book on top. So I have 1/5 and 3/4. We then have to write it as division, keep, change, flip, multiply straight across, and I get 4/15 of her book per hour. And I have my unit rate. So remember, our fraction answers have to be simplified. But other than that, they will generally be a fraction, and that's okay because we are dealing with fractions in this unit. Using that answer, it now wants us to write an equation to show the relationship of how much book she reads in X hours. So equation just is the same as our one from last unit. K, remember, is that number of our constant of proportionality, which was just a fancy way of saying unit rate. I have my unit rate from that first answer. So my equation is y equals 4/15 X. I'm then able to use that equation to answer my next few questions. How far in her book will Maggie be after 1.7 hours? So remember up above it said X is hours. So everywhere I see the X, I'm going to put hours. Now we're dealing with fractions. We should probably have this as a fraction. 1.75 is 1 3/4. And I prefer improper fractions, so that's also the same as 7/4. So I'm going to take that fraction and plug it in for my X value. So y equals 4/15 times 7/4. Remember we talked about how if you have the same number in the numerator as you do in a denominator, the beauty is they completely cancel each other out. So I can cross my 4's out. And I'm just simply left with 7/15. So how far in her book will she be? 7/15 through her book. And there's my answer. Then it asks how long will it take to finish her book? To finish her book, that means she's read 1 book. Books are our y value. So everywhere I see a y, I'm going to put the number 1. 1 equals 4/15 X. And now we have to solve this equation. So 4 divided by 15 times X. I know I can multiply by 15 to get rid of this. So I have 15 equals 4x. And then I can divide by 4. And I get x equals 15/4. If I change this into a mixed number, 4 goes into 15 3 whole times. And 4 times 3 is 12. So I take away 12 pieces. And I'm left with 3 pieces left over. So it will take her 3 3/4 hours to finish her book. Our next problem says Squirt's tank has a slow leak again, and we have a bucket to catch the drips. After 4/5 of an hour, the bucket is 1/8 of the way full. How much of the bucket will be filled after 1 hour? So remember, we are talking about 1 hour. So when I'm finding this unit rate or constant of proportionality, I want hours on the bottom and buckets on the top. So buckets is 1/8, hours was 4/5. Write it as a division problem. Keep, change, flip, and multiply straight across. When I do so, I get 5/32. Can't be reduced, so it's full per hour. So in 1 hour, it's going to fill up that far. We then use that number to write our equation. So we have y equals, my number is 5/32x. Remember, buckets is my y, x is my hours. That's going to help us in the next two questions. 32. So now that we have our equation, we can answer the question, how long will it take the bucket to overflow? For the bucket to overflow, it means we have one full bucket. Now, 1 is a bucket. That's a y value. So I'm going to put 1 in for y. 1 equals 5/32x. When I'm solving, it's dividing by 32, so I can multiply by 32 to get rid of that first. So I get 32 equals 5x. Then to get rid of that 5, I divide by 5. I get x equals 32 divided by 5. It's easier to see hours in mixed numbers. So 5 goes into 32 6 whole times because that's 30. And then I have 2 parts left over. So we'll take 6 hours and 2/5 of an hour to overflow. Our final question today, we're actually going to edit slightly. So if you could cross out what it says currently and then rewrite our new question, which is, how long would it take to fill a bucket 3 times larger? So when we try to answer this question, we can think about, we know how long it took to fill a bucket, a single bucket. If it is 3 times larger, that would be like 3 buckets. So what we can do is, if it takes this equation is for 1 bucket, we could use this equation for 3 buckets because that would be 3 times larger. So we can say 3 equals 5/32x. And then if we solve this, it will tell us how long it took to fill a bucket 3 times larger. So because it's 5 divided by 32, if we multiply by 32 on both sides, gets rid of this. So we have 96 equals 5x. Divide by 5 on both sides. So we get x equals 96/5. Now, 5 goes into 96. That's once. 19 times. And that would be 95. And so we have 1 part left over. So 1/5 left over. So how long would it take to fill a bucket 3 times larger, or essentially 3 buckets? It would take 19 1/5 hours. And there we have it.